Okay, so this is your quick IB chemistry review for proteins. Alright, so first off, we start off with B.2.1 and drawing the general formula of an amino acid or two amino acid isn't that hard. It's just a amino group attached to a carboxylic acid, and the central C has an R off of it. And the R can be anything. It's what defines the acid. So just read that and you're good. Just put the stuff together. Next page, B.2.2. This is describing the characteristics of the.
So amino acids exist in, they have amphitheoric properties in which they have equilibrium between acidic and basic reactions. So the acidic reaction occurs when there's a higher pH, or occurs more when there's a higher pH because the OH minus ions attract the H plus, which has come out, and then it shifts equilibrium towards the acidic reaction. The basic reaction, on the other hand, occurs when there's a lower pH because the added H plus from the pH pull the OH minus that come out from the basic reaction. And when amino acids exist as Zwitter ions, which are both positive and negative ions, they're dipolar. And as you can see in the picture, there's a negative end and a positive end. And that's why this is at equilibrium. And it has a really high melting point because of really high IMFs. So next we have that there's a point where Zwitter ions exist, and that is the isoelectric point, which is abbreviated IH. And it's the pH where the acidic and basic reactions are equal or balanced. So it's like the equilibrium in the center. That's when there's only Zwitter ions. Next we have a property which is buffer action, which is basically that when a pH is added in, the amino acids neutralize the solution. And as you can see in the picture, the end of the, let's say there's an acid, as the H plus is added in, it'll get attracted to the COO minus on the amino acid. And the same way, if there's an OH, it'll get attracted to the NH3 plus, as you can see here. And water is produced as a product. So both acidic and basic solutions are neutralized. And the third, another property is stereoisomerism, and this is because the central carbon of the amino acid is a chiral carbon, and as you can see, it has 4 different ends. So there's 2 possible stereoisomers or enantiomers, and they have optical activity. They're non-superimposable. So the next objective is describing the condensation reactions that form polypeptides, and Ash will come and talk about that.
Radio. Okay, so this process is actually really similar to esterification. So you can see we're going to take an OH and stuff out, or pretty much we take water out and form the dipeptide bond. And then we can see that the nitrile group and the carboxylic acid group are still there, so we can continue with the process. And now we're going to talk about primary structures with C.
Alright, so now we have the primary structure of the 4 structures of the proteins. So for primary structures, it's basically just a sequence of amino acids that form a polypeptide chain, and they're just held together by polypeptide or peptide bonds, and they serve as the backbone of the molecule. So as we see here, these are just 2 amino acids put together and forming a chain. Alright, so next we have the secondary structure, which is a little bit more complex. It's held together by hydrogen bonds, and these just put together the peptide groups, and this just leads to a folding of the polypeptide chain, making it even more coiled. And so there's 2 types of structures, alpha helix and beta helix. And alpha helix, well, there's differences right there on the image and how they look. And basically these have secondary structures are called fibrous proteins, and they're insoluble in water. So now we have the tertiary structure, which is just further coiling of the the R group interactions, and there's 4 types of interactions possible: hydrophobic interactions, hydrogen, ionic, and disulfide. So basically, these are 4 different types of interactions that cause the structure of the protein to fold even more, and this is the most stable arrangement. And they're made up of intramolecular forces, and they're known as globular proteins, which are water soluble. So finally, we have quaternary structures, which is a chain made of more than one polypeptide chain, and they're called subunits at this point, and they're all held together by non-covalent bonds, and so such as like hydrogen bonds and ionic bonds. And they're not as common as the other structures, so because most proteins only have one polypeptide chain. And
Okay, so B.2.5 is chromatography and electrophoresis. Chromatography, well, chromo is color, and graph is, well, just writing. So what we have is a beaker, and then the strip of paper is just touching the water with a dot of amino acid. Now the water is going to go up through capillary action, and eventually we're going to get something that looks a bit like this. So that's the strip of paper now, not the beaker. And the dots are going to be all on different heights because each dot is slightly less soluble. Like each amino acid is slightly less soluble, so it will climb higher or lower. And that's how we can differentiate between them. Alright, so now we go to electrophoresis.
So electrophoresis is another process of separating amino acids. Every amino acid has a different charge because of the differing pH groups or the isoelectric points. So what happens is as an electric charge is passed through a system and the amino acids are placed on one side and they all move, and depending on their specific charges they move a different amount. So some move more based on their charge, and therefore location tells identity. Thank you for listening and watching. Peace.